Plate tectonic evidence, part 3. The evidence of plate tectonics. What are the evidences that support plate tectonics? In history, the late 15 to 1700s, scientists noticed a puzzle-like fit of the continents. In 1912, the German scientist Alfred Wegener found evidences for this puzzle fit. 1912 to 1960, Wagner's theory was not accepted by many. He was very much ridiculed, and like I said, he was kicked out of the Geologic Society. But in 1968, the theory began to be accepted with the help from John Tuzo Wilson. Okay, so there are 7 different evidences, and the first evidences is the puzzle. The continents can fit together like pieces in a puzzle. So here we have South Africa fitting in, Western Africa fitting in right next to South America. The second evidence is fossils, okay? So these ancient reptiles, the Mesiosaurus, they're fossils on separate continents of the same creatures that would never have been able to swim across the ocean. So the fact that in South America along here, as well as Africa along here, the Mesiosaurus was found. And so if you look back how they fit together, of course, they were at one time the same landmass. So these animals flourished along this area. And as you look at it, separate them, we find fossil evidence, number 2. Number 3 is rock formations. There's a matching mountain range on the opposite side of the ocean. So if you look again, when we look at how the continents all fit together, Greenland was in there, North America, South America, Africa, Europe. So we here have, as we talked about in our Jamboard, this is the Appalachian Mountains, okay? And the Appalachians go all the way up through the Europe, okay? And they go up through this area in here. And when they fit together, the rock formations of mountains was continents upon continents crunching each other, right? So there's your evidence. The rock formations matching mountain ranges on opposite sides of the Atlantic Ocean. Number 4 evidence is glacial evidence. There's evidence of a glacier that once covered parts of Africa, Australia, India, South America, and Antarctica. So again, here you are today, and how strange is it that glacial markings and scrapings are so far apart, when really Antarctica fit nice and neatly right into Australia and India, Africa, and South America. So this was all at one point, again, together, right? And as the glaciers moved, they don't just sit there. There's a movement, there's melting, there's scraping, there's evidence of it. And this evidence is across all the different areas to show how they would fit together like a puzzle. The 5th evidence is earthquakes and volcanoes. They occur in limited areas near plate boundaries, used as evidence when you get graphed. And this is known as the Ring of Fire, right? It says it right there. 90% of the earthquakes and 80% of volcanoes occur on plate boundaries. So as we asked you, what do you know from our previous volcano and earthquake unit? You now know, you knew that earthquakes and volcanoes were related, but you didn't realize that it was 90% of earthquakes and 80% of volcanoes occur at plate boundaries. The 6th evidence is the ages of the rocks at the rift and ridge zones, okay? So the rocks in the middle of the ridges are younger than the rocks near the continents. So as we look at these convection cells, and remember we looked at them, they're divergent, so they're pulling the slabs away from each other, okay? Then eventually there'll be a subduction zone and they'll go down, so the circles will look like this, the circles will look like this, okay? So the oldest is on the outside, the youngest is on the inside. So that is evidence of the ages of the rock. We know this by aging them. Rocks are higher in elevation near the mid-ocean ridge. Magma comes up towards the surface and pushes on the land. Lava comes out, hardens, and new crust forms on top. So this is your mid-ocean ridge, and this is how new crust is made, and it's pushing it out. Rocks are younger and hotter in the higher elevation at the ridges. So they're younger and hotter in the higher elevation where the magma has reached the surface and is now lava and creating new crust. The seventh evidence goes right along with the fact that the new, younger rocks are in the middle, and as you go out wider and wider is the older rocks. What also happens in the earth is the reversal of magnetism. So the seventh evidence is magnetism. Some rocks contain magnetic minerals, example of magnetite. As the crystals form in the cooling lava, the magnetic minerals line up toward the poles of the earth, towards the north and the south. So, about every million years, there's a reversal of Earth's magnetic poles, okay? And that reversal says that these now crystals form in the opposite direction than before. It all has to do with between reversals, it's a very strong north-south. But during a reversal, there's a whole lot of changing and moving, and then eventually it straightens out and the poles reverse. Okay, so the crystal formation that may point north at the end of the reversal, it now would form and point south. So on the ocean floor, there are alternating bands of magnetic minerals pointing north and south. These bands show symmetry with the other side of the mid-ocean ridge. What does symmetry mean? Same. So here is the brand new lava creating the new crust, the youngest crust, and the minerals are cooling and facing north. But we look on equal distance, symmetry same, the same distance apart, there's a section where the minerals were facing in the opposite southern direction. And we go out from there, and now they're switched again. They're back to north, and there's a width for north, and then they go to south again. So that's not only is it youngest to oldest, but they are the same. There's a symmetry, meaning the same width on both sides. The crystals form in the same magnetic direction. And when it reverses, that's why they reverse, and they go from north to south to north to south. So if we start with the rocks here, and the magnetic north is up, okay? As they separate, because, right, we're getting new and more new crust in here, okay? We get more crust, new crust, again, symmetry, the same distance on both sides, okay? Now, all of a sudden, we get a reversal, okay? So now, we've got the reversal, and now all of the crystals are pointing in the southern direction. And then it switches again, and it goes to the north. And then it switches again, north-south, north-south. So if you look at any one point, they're both pointing down in this gray-blue. The orange are up, then the purple are down, the blue are facing north, the green are facing south, the red are facing north, and it just so happens that the gray are north as well. So the youngest rocks in the middle have the same width on both sides, symmetry, and the oldest are on both edges.